To solve quadratic equations by factoring, we need to take advantage of something called the zero principle. The zero principle states that if you have a product of two numbers or two quantities equal to 0, then either one of them is equal to 0 or the other one is equal to 0. So let's apply this to a fairly straightforward quadratic equation and try to solve x squared minus x minus 2 equals 0. So we already have a 0 on one side. That's the first thing out of the way. If we didn't have 0 on one side, we'd have to bring everything over to one side. So now we have to write the left-hand side as a product. And that's another way of saying we have to factor it. So to factor the trinomial on the left-hand side, we're looking for two numbers whose product is negative 2 and whose sum is negative 1. And those two numbers are negative 2 and positive 1. Now we have our product equal to 0. We can say that the first factor, the first quantity, x minus 2, is equal to 0, or the second quantity, x plus 1, is equal to 0. And at this point, you have to realize you've done something quite amazing. You've turned this fairly complicated equation, quadratic equation or polynomial equation of second degree, into two much simpler equations, two linear equations that are quite easy to solve. To solve the first one, we just need to add 2 to both sides. To solve the second one, we just need to subtract 1 from both sides. And so we get, that should be negative 1. So we get two separate solutions here. And anytime you solve an equation, it's always a good idea to check to make sure they are valid solutions. To check that 2 is a solution, we're just going to replace x in the original statement with 2, and we get 2 squared minus 2 equal to 0. So that's 4 minus 2 minus 2. In other words, 0 equals 0. So it has to be a true statement in order for it to be a correct solution, and this clearly is. So let's try this again with a slightly more complicated quadratic equation. 6x squared plus x equal to 2. Now, first thing we notice is that as soon as we identify that it's a quadratic equation, we have to get everything onto one side and have 0 on the other side if we're going to use this technique. So I always like to collect the terms on the side that give me a positive coefficient for the x squared term. Since that's already the case, I'll bring everything over to the left-hand side. And I have 6x squared plus x minus 2 equal to 0. To factor this trinomial on the left, we can do it a couple of ways. One way is to factor by decomposition, and the first step is to look for two numbers that have a product of 6 times negative 2, the first coefficient times the last coefficient, and a sum equal to the coefficient on the x term, which is positive 1. So those two numbers are negative 3 and positive 4. And you use those two numbers to break apart this middle term and rewrite it as two separate terms, negative 3x plus 4x minus 2 equal to 0. You then factor this by decomposition, which means you break it apart into two separate pairs. And you look for a common factor in the first pair, which is 3x. And that leaves you with 2x minus 1. And you look for a common factor in the second pair, which is 2, leaving you with 2x minus 1. And if you've picked the numbers negative 3 and 4 correctly, then you're guaranteed to get a common binomial factor, which you have in this case, 2x minus 1, and that leaves you with 3x plus 2. So now that we factor the left-hand side, we can take advantage of this zero principle. Either the first factor, 2x minus 1, is equal to 0, or the second factor, 3x plus 2, is equal to 0. And these, while they're not quite as easy linear equations as the ones we saw in the first example, they are still pretty simple to solve. I'll solve the first one by adding 1 to both sides, and then dividing by 2. And I get x equal to 1/2. On the next one, I'll subtract 2 from both sides, and I'll divide both sides by 3, and I get x equal to negative 2/3. So we have two solutions, and you can check that 1/2 and negative 2/3 are valid solutions just by substituting them back into the original statement. You're not going to be able to solve every quadratic equation this way because not every trinomial will be factorable. But if you can factor it, this is quite a nice, efficient way to solve a quadratic equation.